Hey, we are here with the impulse practice problems. Number 1, when the force of impact on an object is applied for a longer time, does the impulse increase or decrease? And we want an example here. So recalling that impulse equals force times time. Sure, if I increase the amount of time the force is applied for, the impulse will also directly go up with that. An easy example there, is following through in sports, right? So when you follow through on your swing, whether it's tennis or golf, you're maximizing the time of impact so as to increase the impulse so that the ball leaves with a great amount of momentum to go over the net, onto the fairway, whatever your sport is. All right, number 2, does impulse equal momentum or a change in momentum? So we just want to clarify here, right? When an impulse is applied, it is changing the momentum, that's what this delta symbol means, of the object, right? If the object has no change in momentum, otherwise this would then be equal to 0, there would be no impulse. Okay, number 3, right, during a fire, a person jumps, I don't know why I giggled there. This person's jumping, they've got the net right here, so, and they're gonna be fine, right? Why is the net beneficial? So obviously here, we need to change the person's momentum who is jumping, right? So they're falling, they're gonna have some initial momentum here, and we wanna make their final momentum, once they finally hit, we wanna make that 0, right? So to do that change of momentum, we can play around with the force and the time. The impulse is the same regardless of whether they hit the ground, unfortunately, or hit the net. So if we can make this time longer and increase the time, then that will decrease the amount of force proportionally, and the person will be much safer in the fall. All right, number 4. Oh, a little review from our watermelon drop. From our sports figures video we checked out. Yeah, let's see. So whether the watermelon falls on the concrete or lands in the water. So change of momentum will be the same for both, right? Because we're going to decrease the watermelon's momentum to 0, right? It's going to go from some initial momentum to a final momentum of 0 both times. It's just, do you want it to hit the concrete or the water? So if it lands on the concrete, it's obviously destroyed, and this is going to lead to a much greater force on the watermelon for the concrete. And that's because the time of collision is less. It's very short. Conversely, if we increase that time of collision between the watermelon and the water, right, it's going to go through the water and take a lot of time to come to a stop, be a greater time, so that will make the force a lot less, and the watermelon does not break or crack or be destroyed. Okay. All right, let's check it out with some problems here. It's Lewis and the squirrel, first of all, right? So we're driving down the road at 20 meters per second, and the squirrel jumps out in front of the car. He's got to slam on the brakes, right? So what's the initial momentum of Lewis? So that's the person, right? So we've got to figure out the initial momentum is just his mass times his velocity. So 75 kilos times 20 meters per second. And if I do that on my calculator here, I've got it. 20 times 75, that's 1,500 units of momentum, or since we're multiplying kilograms and meters per second. All right, the final momentum of Lewis, well, he's going to stop, right? His final momentum is going to be 0 in the car. And henceforth, the impulse will be equal to the change in momentum, right? So whether that impulse is exerted on him by the windshield or by an airbag or the steering wheel, right? There's obviously one he prefers. But that change in momentum, it's the final momentum minus the initial, right? So his final momentum is 0 minus the initial of 1,500. So this impulse will then be negative 1,500 kilogram meters per second, right? And that negative signifies that our momentum is decreasing. So it says if the seatbelt brings him to rest in 0.4 seconds, what's the force applied to him? So that's impulse as force and time together. right? So if our impulse is negative 1500, and we want to solve for the force when the time is 0.4 seconds, so I'm going to have to divide here, and I will get a force. If I take 1500 divided by 0.4, that's going to be a big force, 3750 newtons of force. But he's going to be able to deal with that, right? He'll be okay with the seatbelt. If he was not wearing the seatbelt and hit the windshield in 0.001 seconds, how much force is he going to feel? So that is definitely not going to be a happy moment there. So let's see, if we do that, same change in momentum, but now what's the force when the time is super short, right? 0.001 seconds. So if I divide 1500 by 0.001, I'm going to get, well, that's a big force, right? That's 1,500,000 newtons, right? So that's not going to be a great thing for him to feel all that force in such a short amount of time. Okay, so why is the force different? Well, hey, that's all about time, right? When we increase the amount of time, we can decrease the amount of force for our impulse to change their momentum. All right, last prob, number 6. We're golfing, taking some swings. So, yeah, a golfer drives a golf ball off the tee at 28 meters per second. The club was in contact with the ball for 0.006 seconds. So, on the follow through. So, what's the initial momentum of the golf ball? Well, it's just sitting there at rest. So, its initial momentum is 0 on the tee. As it leaves the club, it's going to have momentum now because it has a velocity. So, 0.045 kilograms times a velocity of 28 meters per second. So let's get that calculator going again. 0.045 times 28. I've got 1.26 units of impulse, which we're taking newtons times seconds. So those are the units of impulse there. Oh, I'm sorry. Well, I mean, that's going to be the impulse, right? I just kind of answered C. So the impulse equals the change in momentum, right, which is the final momentum minus the initial. So it would be 1.26 minus 0, or 1.26, right? So those units, right, whether it's kilogram meters per second, they're the equivalent units. So a newton second is the same thing as a kilogram meters per second, okay? So I'll keep this as kilogram meters per second, everybody. All right, so how much force did the golf club apply to the ball? So that's impulse is force in time. So if the impulse was careful. So if the impulse was 1.26 and the force was applied for it during a time of 0.006 seconds, right? If I just divide both sides by 0.006, I'm going to get a force of, where's my drum roll? 1.26 divided by 0.006 seconds. So it's 210 newtons of force that she hit the golf ball with. Ta-da! Or I should say 4. 4?